According to official records, humanity's journey into space began on October 4th, 1957, when the Soviet Union successfully placed Sputnik 1 into low Earth orbit. Since that historic moment, many things have changed. Yet despite all our technological progress, we have managed to land on the surface of only 3 places: the Moon, Venus, and Mars. But what if your path led you to the planets of our solar system? Would you be able to survive there? In 1961, the Soviet Union set its sights on Venus with the launch of the Venera Program. As part of this program, a total of 16 Venera probes were built for missions targeting Venus. Finally, in 1982, Venera 13 successfully passed through the deadly clouds dominated by sulfuric acid and landed on the surface of Venus. After landing, it operated for 127 minutes, an achievement that can be considered a record, during which it transmitted the first color photographs of Venus, analyzed the soil on the surface, and sent back the unique sounds of the planet to Earth. The conditions on Venus were extremely harsh. The pressure was high enough to crush a tank, and the temperature was high enough to melt lead. Due to the extreme pressure and temperature on Venus, Venera 13 shared the same fate and was destroyed after 127 minutes. Now, let us imagine for a moment that our path led us to Venus. How long could we survive there, and would we even have time to explore anything? Let's take a deeper look. Today, even with a sweatshirt or with any spacesuit we currently know, we cannot land directly on the surface of any planet. We would most likely be dead before a single blink of an eye. However, for the duration of this journey, until the video ends, I want you to imagine wearing a suit designed to visit planets, one that tightly encloses your body. Yes, we said our first stop would be Venus. The atmospheric pressure on Venus is equivalent to the pressure found 900 meters below the surface of the ocean. You can be certain that this level of pressure is more than enough to crush the human body instantly. As you take a look around, the first thing you notice is the yellow and orange hues covering the entire planet, caused by dense carbon dioxide and sulfuric acid clouds in the atmosphere. The planet's constant twilight severely limits visibility, but even in clear conditions, all you would see are vast, rocky plains filled with volcanic stones. Your spacesuit has been reinforced with plates made of titanium and special composite materials to withstand Venusian conditions. Since Venus's gravity is only about 10% lower than Earth's, you feel the full weight of the suit pressing down on your joints with every step you take. On Venus, the dense atmosphere creates an intense greenhouse effect, raising the surface temperature to around 470 degrees Celsius, which is approximately 878 degrees Fahrenheit. This makes Venus the hottest planet in the solar system. To put that into perspective, metals such as lead or tin exist in liquid form at these temperatures. Fortunately, before arriving here, we upgraded your suit with a heat shield and an internal cooling system capable of withstanding temperatures of up to 500 degrees Celsius, or about 932 degrees Fahrenheit. You walk across the surface of Venus without knowing where you are going, but your muscles are already exhausted from the weight of the suit. And before long, things begin to get worse. Even though the suit is an advanced version, the cooling system is the first component to fail. Once it becomes inoperative, the suit starts issuing warnings, and at the same time, you notice the temperature rising inside. Almost immediately, you begin to feel dizzy. The heat stroke has already begun. Before you can fully understand what is happening, you lose consciousness and collapse to the ground. During the same time frame, sulfuric acid and extreme pressure begin tearing holes in the suit. In less than a minute, your body temperature reaches a level incompatible with survival, and the suit becomes completely unusable. You manage to survive on Venus for approximately 20 minutes, a striking start. Our next stop is Mercury, the smallest planet in our solar system, and also the closest one to the Sun. Your capsule makes a controlled landing on the dark side, because we already know that surviving on the sunlit side would be impossible. Since Mercury has virtually no atmosphere, there are extreme temperature differences between its day side and night side. Daytime temperatures can reach up to 427 degrees Celsius, while at night they can drop as low as minus 173 degrees Celsius. If you have ever seen the moon in photographs, this landscape will feel familiar, because Mercury is almost a twin of the moon, a surface dominated by shades of gray, covered in craters and deep fractures. Standing where you are, watching the stars may be the best activity available to you, because they are all you can really see. On the dark side, with no external energy source, you can survive only until your suit's power runs out. That time is limited to just a few hours, and once the suit loses power, you would lose consciousness within seconds, followed shortly by death due to exposure to the vacuum and extreme cold. Now, let's assume your suit never runs out of power and is reasonably resistant to radiation, such as that produced by galactic cosmic rays. In that case, you could survive for as long as your body allows. But even then, this duration is limited to 88 Earth days, because a single solar day on Mercury lasts 176 Earth days. In other words, if you landed at the point where the sun had just set, the sun would rise again after 88 Earth days. When it does, you would be confronted with a sun that appears 3 times larger than it does from Earth, blindingly bright and overwhelmingly white. Temperatures would rise rapidly, and although your suit may be radiation resistant, it would be unable to cope with the immense thermal load produced by direct solar exposure. First, the suit's climate control system would fail, followed by all electronic systems. As extreme heat overwhelms your body and protective systems, the pain would eventually cause you to lose consciousness. Mercury's hospitality lasts no more than 88 days. Of course, depending on your preparation and your endurance, the time could just as easily be reduced to 15 minutes. Now it's time for a short journey to the planet that is more famous than any other on Earth today. The red planet, Mars. And don't be fooled by the word short. Once you arrive on Mars, the time you can spend here may be significantly longer compared to the other planets. Under today's conditions, Mars is the only planet in the solar system where long-term survival is even possible. Knowing this alone can be reassuring. Those who planned your journey decided that your capsule should land near the equatorial region, close to Gale Crater, near the coordinates of the Curiosity rover. To help you feel more comfortable at first, the landing is scheduled during daytime hours in the Martian summer. At this time, temperatures near the equator can rise to around 20 degrees Celsius, or about 68 degrees Fahrenheit. But once the sun sets, conditions change rapidly. Nighttime temperatures can drop to minus 70 degrees Celsius, roughly minus 94 degrees Fahrenheit. For this reason, the suit you are wearing is designed not only for daytime conditions, but also to withstand the freezing cold of a Martian night. A single solar day on Mars is slightly longer than a day on Earth, about 1.03 Earth days. Gravity, however, is only about 1/3 of Earth's. This allows you to walk for hours without fatigue and cover distances that would normally be impossible. But this sense of lightness and freedom is deceptive. Radiation levels on the Martian surface are approximately 20 times higher than on Earth. Over the long term, low gravity combined with high radiation disrupts the circulatory system increases the risk of cardiovascular disease, and negatively affects brain function. In the short term, however, there is a more immediate limitation: energy. You can wander for hours, but after a few hours, your suit's power supply will begin to run out. Once the energy's gone, your oxygen supply is cut off as well. This is why the most basic requirement for survival on Mars is a continuous and reliable source of energy. Jupiter is without a doubt the most charismatic planet in our solar system. If your path ever leads you to Jupiter, you will never reach a surface, because Jupiter is not a solid planet. It is a place where you would experience continuous free fall. Fortunately, you would not fall forever, because your survival time here is limited to just a few minutes. As you enter the upper atmosphere, everything seems calm at first. You drift between colorful layers of clouds, but this is a brief illusion. As you descend deeper, the atmosphere rapidly becomes denser. Winds reach speeds exceeding 500 kilometers per hour. And due to intense turbulence and sudden changes in velocity, your body is exposed to extreme g-forces. Within minutes, the pressure surpasses even the values found at the deepest points of Earth's oceans. At this stage, the human body cannot withstand it. At the same time, the temperature rises rapidly. What begins near the freezing point in the upper layers quickly climbs into the hundreds and then thousands of degrees Celsius. Gases compress and surround you like an overwhelming, crushing mass. While all of this is happening, Jupiter's extraordinarily powerful magnetic field and lethal radiation cause irreversible damage to the human body. In the end, Jupiter takes control first, then crushes you with pressure, and finally destroys you with heat and radiation. Today, there is no way for humans to enter Saturn's atmosphere. But for a moment, let's imagine that we could. The end would come quietly and faster than expected. Saturn is, by nature, similar to Jupiter and is not a solid planet. However, at first glance, it does not appear as wild as Jupiter, which can make it seem calmer than it truly is. As you enter the upper atmosphere, temperatures hover around -170 degrees Celsius. Drifting through thin layers of gas composed mainly of hydrogen and helium, an unprotected human would lose consciousness within seconds due to the lack of oxygen and the extreme environmental conditions. As you descend deeper, the atmosphere becomes increasingly dense. Saturn's winds are among the fastest in the solar system, reaching speeds of over 1,800 kilometers per hour. The intense turbulence and sudden accelerations created by these winds have devastating effects on the human body. As pressure rises rapidly, the environment quickly exceeds the limits the human body can withstand. In addition to all this, radiation associated with Saturn's magnetic field, while not the primary threat, accelerates the damage to the body. Under these conditions, the outcome becomes inevitable. As we leave the inner regions of the solar system behind and approach Uranus and Neptune, we can sense from the very beginning that we are about to experience something entirely different. There is a single word for it: cold. On both of these planets, the end arrives in a similar way, not as a sudden catastrophe, but as a slow and inevitable one. This is because they lie in a boundary region where the sun's influence has almost completely faded. Uranus and Neptune are ice giants with no solid surface. Much like Jupiter and Saturn, there is no ground here to stand on. As you enter their upper atmospheres, temperatures drop below -200 degrees Celsius. Moving through clouds of hydrogen, helium, and methane, an unprotected human would lose consciousness within seconds. What sets Neptune apart from Uranus is that it has the most violent winds in the solar system. with speeds exceeding 2,000 kilometers per hour. Our knowledge of Neptune is also limited. It is based almost entirely on the brief visit of the Voyager 2 probe in 1989. Finally, let's take a look at Pluto. Expelled from the solar system's planetary family years ago. We are no longer talking about planets, but about the edge of the solar system itself. Here, the sun appears in the sky as nothing more than a bright star. Temperatures fall to -230 degrees Celsius. Since Pluto has no atmosphere, it is possible to take a short walk on its surface. However, faced with the lack of oxygen and the extreme cold, your suit would fail within minutes, and you would lose consciousness. Yes. We have now completed our short journey through the solar system. You now have a clear understanding of what would await you if your path ever led you to any of these planets. So, which planet do you think was the most unforgiving? Let's meet in the comments. Until the next video, take care.